There we go. Right, share. No.
Okay, we can see your desktop, I think.
Yeah, totally wrong one.
Okay, try again.
So I'm going to start talking anyway while I try and click and get this stupid technology. My computer's decided to go really slow. So let me start talking without slides. I'm going to be talking about a tool called Grafana Tanka. It's a utility for working with Kubernetes. So you probably come across Helm. It does a similar job. In my personal view, it does it better. But what would be really useful, and my computer's completely refusing to accept the...
Do you want me to show you the slides? So I can show your slides. You can speak to the slides if you want.
Yeah, I was going to give a demo as well. Oh, there it's gone. Good, it stopped. Okay, so the first question I'd like to just start is just by getting a sense of people here. Just ask what experience could you put something into the chat and just tell me what experience you have of Kubernetes. Are you a Kubernetes noob, or are you one of the co-authors? Okay, great. That's so a mixture of, I see a mixture of levels of skill. Okay, so I think we're going to do without the demo, and I'm going to let you do the slides.
Okay, just say next slide and I'll spin it on.
So let's go next. So let's go on to the next one. Right, so what is it? It's a tool for managing Kubernetes resources. Keep going. And it does it in a way that scales well. So next. So how does it do this? First of all, it it avoids templates. So if you use the Helm model, what you're doing is you're working with YAML files. So Kubernetes. In order to configure Kubernetes, what you have to do is to create YAML files. And those YAML files, as I'll show you an example later, give you a lot of detail about what the things are, what the resources are that should be configured. So it's a declarative way of describing the things that should run on your Kubernetes cluster. What tools like Helm do is they say, here's some YAML. Oh, and let's put some template nodes in them. So, and that just, it mixes two completely different programming styles on top of each other. So this avoids that. I'll explain how in a minute. It also handles environmental differences very well. So, if you have a development environment, a staging environment, production environment, maybe for production environments, you have 5, 10 different clusters. So we have about 10 or 15 clusters at Grafana. We manage them all with different with Kubernetes, with Tanka in this way. One of the really neat things about it is in working with Kubernetes, you need to render YAML, obviously, because that's what Kubernetes expects. But we also are likely to work with applications that don't expect YAML. So, for example, Grafana is configured with an ini file. But also you can specify dashboards with JSON. So all of that can be done. So you can output resources that can be consumed by your resources in Kubernetes, which allows you to build in quite a rich set of functionality. But I'll say more about that as we go. So there I was leading on to it, supporting multiple layers of abstraction. And also it supports a an increasing ecosystem of open source libraries. So let's go to the next slide. So how did it do this? Keep going. So first of all, quick recap. What we see here is we see a snippet of YAML, and you can see, for example, how verbose it is. So you can see the word Grafana mentioned 4 times, and then the Grafana image. It's getting a bit old now, that version, but the only 2 key pieces of information in this YAML are the word Grafana and the image URL name. And really, that's all we actually want to specify. Everything else can stay much the same. So let's go next. So how do we do that, all this? Well, we use a programming language called Jsonnet. So Jsonnet is a superset of JSON. So any JSON is also valid Jsonnet. The thing that's unusual about it is that Jsonnet simply renders, when you run a Jsonnet script, a program, the output is actually JSON. So it doesn't do anything, it results in JSON. And that's incredibly powerful for your typical configuration situation. So for example, if we look at this example here, you can see at the top we have a local variable called greeting. Near the bottom it says nested : greeting. There's a reference to that global. You can see that we have in our JSON-like language, there's a few syntactic tricks like removing the quotes, so you don't have to do quite so much typing. And then you've got a neat little thing at the bottom, hidden : So this is an element that's available to your program, but won't end up in the output. We'll see a use of that on the next slide, I think. So here we can see you've got an element called Grafana, which uses the : it's hidden, and it specifies an image and a version. And then you've got another element called images, which isn't hidden. And then you can see quite a common programming pattern where you use interpolation %s : %s, and you pass into that is the outer node. So that's the outer bit of your whole program. .grafana.image and also $.grafana.version, and you end up with Grafana /Grafana 6.6.0 as you see on the right. And then we do another trick where we say self.image. Self is the same parent, so that's images, and then we add on dash Ubuntu. Yep. So as you can see, we've just got these 2 neat. You can see on the right the JSON that resulted from it. If we go to the next slide, you'll see here we're doing exactly the same thing. This time we're doing it with a local variable. And you can see at the bottom left, you see Grafana.image and Grafana.version, but apart from that, the output is exactly the same. So if we move to the next slide, here you can see this is getting a bit more complex. What we've got here is a function. Actually, we've got an element called deployment, and that element has within it a function called new. All that function does is it has 3 parameters, 3 arguments. : means it's hidden because you can't put a function into the output. So, but what that function will do is return a snippet of JSON, and into that JSON it inserts some values. So you can see in their name and image. But now if you look right at the bottom, you see 4 lines: deployment.new, name equals Grafana, image Grafana 660. So that if you want to create a deployment for a Kubernetes within Kubernetes, a deployment resource within Kubernetes, and typically your deployment resource definitions will be a lot bigger than that. All you need to do to create the basic thing is those 4 lines. And you could put those in a loop, you could have many of them, and so on. And on the right hand side, you see the snippet of JSON that would come out of that. So if we go next. So here we have, we're just seeing simple importing, so you can spread your code over multiple files. So you can see here we're importing from common.libsonnet at the bottom. At the top you see the file, and we're just importing some labels, and there's a few tricks. If you see, it says on the bottom left metadata plus, labels plus. What that says is merge with any of these elements that already exist, don't overwrite. So if you want to do a deep merge, you can do that, which is extremely useful. That's the Jsonnet patching functionality. So if you go next. Okay, so I would give a demo. What I'll do, let me have a go and see whether it's going to let me do it. Yes, it is. Okay, great. Okay, so we can see, let me make this a bit bigger. Okay, so what we've got here is, this is an example that I've used at a previous, at the Grafana conference, slightly customized. So if I've got a, if I do K3D LS, so K3D, if you ever want to play with Kubernetes, try K3D, it's really neat. It runs a very small Kubernetes inside a Docker image, which is just a bit nuts. So I've got one here, as you can see, called Bristech. So if I do kubectl get ns, you can see I've got, there's my my system, my namespaces. It's already running. It's been running for 30 minutes. I use my shortcut for kube control get pods. There's nothing there. So let me have a look at Tanka simple, and let me have a look at what we've got here. So what you see, we've got a library here, or two libraries here, that I use to make working with Kubernetes simpler. So the deployment.new is all defined in there. We won't bother looking at those. What we see here is an environment. So an environment typically maps to a single namespace in a single cluster. So if you have many clusters with the same namespace in all of them, you'd have one environment per cluster, per namespace. You've got some files here. These files here, that configures a Grafana instance. This tells Grafana how to install dashboards, and this is a dashboard. This spec.json tells Kubernetes, tells Tanka where Kubernetes is, and this is the real thing. So this main.jsonnet is the real core to everything. So let's have a look at that. So what we got here, we define these, as you can see here, these are really just shortcuts. They just shorten strings down. So let's keep going. So we've got some configuration. How many replicas do we want? We've got some images, the name of the image we want. These are just conventions. And because they're : they're hidden. They won't result in the output, but they're available to us to reference later on. So in Kubernetes, we can create these things called config maps. Config maps really just contain files, contain data, and you can then mount those config maps into a container. Excuse me. So here we first of all we create a config map telling Grafana how to about these two dashboard files. So how to provision dashboards, and this is a dashboard. But then we create another one with some ini files and ini files to tell Grafana to use light mode and the light theme and so on. Then we say create a container or Grafana container, container.new. Give it a name, $.images.grafana goes up to the top, gets the image name. So now we've created a container and we've assigned it to a local variable. Now we say set a port, give the port a name, HTTP, and give it a port number. And then we configure it with some environment variables. We're passing in a map. That's what the word map there refers to. And this map says, here is an environment variable that tells Grafana where to get its ini file from. So now a container isn't a first-class citizen in Kubernetes. It needs to be, needs something to refer to it. So we use a deployment. So here we create a deployment. We give it a name. We tell it how many replicas we want, number that was up above, and we give it the name of we refer to the container we've just created. So we're keeping this pretty concise here, aren't we? We've now created our deployment, and here what we can do is something really, really neat. This, for me, really shows the power of anyone who's familiar with working with Kubernetes and mounting config maps into Kubernetes will know what you have to do. You first of all, you mount the volume, you declare the volume in the deployment, and then you have to go to the container and mount the volume into the container, and it's just unnecessary faff. So here we have a utility function, config volume mount. We tell it, here is the config map, and here's the path I want it, please. And now in one line of code, we've done what would have been 10, 15 lines. So we've now mounted our two config maps. And the last thing we do is we create a service. And we want the service to have a named port, mapping port 80 to port 3000. And if I do it with a load balancer, as a type load balancer, then I can get access to it easily from outside of Docker, outside of K3D. So I'm sure people will have questions on there. If you do have questions about what on earth any of that means, feel free to type them in the chat, and I'll read and answer them after I've finished. So what we want to do now is we can do tk show environments default, and this shows us the full summary. This shows us all of this. This is the dashboard that you can see, all the JSON. That's why you're seeing JSON. As we scroll down, as you can see, as you scroll down, you can now see here is a snippet of YAML and so on. Here's the service definition. So this service was definition was 3 lines, and now there's quite a lot more there. And here is the deployment. All of that was created with about, what's it, like 4 lines of code. Yeah. So I think I saw a question come in, which I'll answer very briefly. So if you see this reference up here, k.libs on k, referring to Kubernetes, what that does is that's an auto-generated library generated from the Kubernetes API Swagger definition. So, and we're just working on a new version of that that's going to be kept up to date, so you'll be able to have a version of the Kubernetes API specific to your Kubernetes version. So 1.14, 1.15, 1.16, and so on. Yeah. So those will be auto-generated for you, and will encapsulate. We'll make the API that you use to interact with Kubernetes available to you in a much more concise form. So let me quickly whiz through to where it says, so prove it. So let's carry on. So repetition is annoying, isn't it? It's time consuming when there's a lot of code. Now you might think that wasn't very much, was it? But let's see if we can do it in less. So the way we do it is we use abstraction. At least we use more of it than we've already seen. So we can use imports to structure our code. There's a tool called Jsonnet bundler that allows us to consume public libraries. So typically installing them directly off GitHub and places like that. And we can use import to extend existing libraries. So we can encapsulate complexity and make a result that's simple and easy to grasp. So there you go. There's an example of a command, JB install and the GitHub path, and that would like a Go vendoring, old style vendoring, that would pull that resource into a directory called vendor in your local checkout, and you'll be able to import it and use it in your code. So what sort of packages do we have? Commonly, we might have application modules. You want to install Memcache, you want to install Cassandra, all the usual things. We also have monitoring mix-ins. So you want to monitor your code. What's that mean? Well, you want Prometheus configuration, you want Grafana dashboards. There's libraries you can import and just run them, and they will talk to Grafana and they will get your dashboard set up. It's extremely powerful stuff. And helper utilities, you know, like we saw the config map stuff. So prove it again. Okay, so let me show you what I'm talking about there. Okay, so here we have much the same thing in this directory, but what we'll see is we've also got a library called Prometheus Jsonnet, or at least we've got the Grafana portion of it. So this library knows how to install Grafana. It's as you can see, the name is called Prometheus. So it's all about installing Grafana for Prometheus, and there's various things it didn't do, but it doesn't quite do. So I created my own little library called Grafana lib myself, and that sort of just tweaks and wraps it and makes it do what I need. So, and we've got much the same set of files here. So let's have a look at my environment's default main. That is all it takes. Now that I've got a library in place, that is all it takes to deploy my improved improved setup. So what I can do is I can do tk show environments default, and we should see it all as before. But what I'm going to do now, tk apply environments default, and we get to wait a few minutes, a little bit. So what it's just done is it's shown me a diff so that I can tell what impact is my change going to have. So you can review whether I'm going to be damaging anything or not. Yeah, and I know I'm not, because there's nothing there to start with. So now we can see here, this is the external port on the service, so I'll be able to use that IP address to access Grafana. And there you go, Grafana is already running. So I can now switch to my browser, 172.18.0.2, go. And here we have a Grafana running that we've just installed. And better than that, we click here. We should be able to click there, and we see there's a scope, so they didn't rename the folder. There we see a GrafanaCon dashboard that we've just deployed inside our Grafana. So in my book, that's pretty cool, and it's not any significantly harder to deploy Grafana to deploy 100 dashboards compared to one. And I will show you one last thing. I won't deploy it, but Tanka, find. Actually, if I look here, actually, I remember it's in lib dashboards. If I look here, let me look in one file, lib dashboards memory, lib dashboards memory. So here you can see this is Jsonnet, but this Jsonnet is not intending to create Kubernetes resources. This Jsonnet creates Grafana dashboards. Here's the dashboard name. Here's a template variable. Here's a panel to go on the dashboard. Here's the format that it's going to have, the title of the panel. the data source it's going to connect to. Here's the Prometheus query it's going to execute. So really, really powerful encapsulation, and all of that is squashed down and embedded into your Grafana all for you. So that gives you a good sense of the scope for encapsulation that's made available here. So we can share this link with you afterwards somehow. I'm sure Nick will find a way to get it out there. This is the code that I've just shared, is available on GitHub, so if you want to review it. If you want to find out more, go visit the Tanka website. There's a really good tutorial on there that will tell you, take you step by step through the concepts behind using Tanka, and do let us know on Twitter how you found it. So thank you. Any questions?
Super. Before we have questions, maybe we could all unmute and show our appreciation for the excellent talk. Fantastic. Okay, so questions. So questions will be curated by Chris. And so if you do have any questions, please do put them in the chat window, and then we'll ask you to unmute and ask them in person.
Cool. Yeah, so we've got a question from Neil Andrassi. Do you want to unmute and ask your question, Neil?
Yeah, it was fascinating to watch, to see, but I was just wondering how easy it is to integrate with GitOps automation, and we're using Flux, but things like Argo CD as well, perhaps.
I think I would say we're about to find out. But as I understand it, there is a there has been some correspondence, I think, with some of the Flux authors, for example, and there is a space in which you can create where you can, instead of just saying Flux deploy this YAML, you can say Flux call Tanka, generate some YAML, and then push that. So there are natural integration points, but we're looking at doing that.
Sounds a little bit like the integration with Kustomize, actually, between Flux and Kustomize.
Yeah, I suspect, yeah, exactly, yeah. Probably very similar.
Cool, thanks.
Cool. Yeah, I'm just wondering, what's the unique selling point of Tanka, and what's the competition?
I'm not hugely clued up on the competition, but Kustomize was mentioned. Well, I mean, the obvious competition is Helm, but I don't tend to consider it competition, because it does a very, very different job, and conceptually it's a very, very different beast. There's things like Kustomize. There's a tool called Quebec. There's a number of, there's quite a lot of tools that do a similar thing. I think you have one level which is thinking about it in terms of it's a templating problem, and then there's a next step, which is to say, actually no, it's a programming problem. So it's a question of which level you tackle that at, and Tanka's definitely one of at the programming level.
Right, so it's kind of similar to the difference between Terraform and Pulumi or something like that.
Yeah, yeah.
Okay. And does Tanka use Tanka? Does Grafana use Tanka?
So Tanka is a follow-on from a thing called Jsonnet that was created by a company that was acquired by VMware, who then deprecated it. So we had such a huge, substantial install using Jsonnet. That was it was inconceivable to do it any other way. So we wrote Tanka to solve our problem, and then we've open sourced it, and we're encouraging other people to use it to, solve the problem that Jsonnet was originally solving. And yes, we make incredible. I mean, when I joined the company, it was already well in use, and I have to say, I saw it and I was blown away with the sophistication and complexity of what their stack builds. In 15 minutes, I can deploy to a new cluster. I can have deployed Prometheus, Loki, Grafana, a suite of Kubernetes monitoring dashboards without it, yeah, just really, really powerful.
That's amazing. I had no idea. I'm going to be looking at this tomorrow, I think.
Yeah, if you use Kubernetes, have a look.
Yeah, especially Jsonnet. It's the best thing you've never heard of.
Yeah,
heard of it.
yeah, and it's really powerful for other things. So you know, anything that where you have sort of a verbose JSON or verbose YAML or something like that, it's a great tool for that.
Great, thank you. That's brilliant. I've learned something great.
I've got one. Can I just ask one question? So if you're introducing, you know, sort of code like syntax for configuration, then obviously code has tests. What's the correctness test for you for the actual infrastructure that's being spun up?
That's a very good question. So testing is yes. So firstly, the way we do a lot of our testing is, you know, if you test testing, is this code doing what I think it should do? Before you saw the TK apply, it gives you a diff. You can review what you're doing. But if you're talking about, am I testing my Tanka code, my Jsonnet code, or am I testing, is the infrastructure what I really want it to be? That's a whole other thing. And that's where the power of being able to deploy not just the application, but to also deploy your monitoring and observability stack alongside. So deploying your application, but also your Prometheus, also your Grafana, and also all of the resources that those things need in order to monitor everything. So your applications having labels, and Prometheus being configured to automatically monitor anything that has that label. So Prometheus now is automatically pulling metrics from your applications, and your Grafana dashboards are all deployed into Grafana, all told to point at those metrics at that Prometheus. So now what you have is not just what we normally do. A very common way of working is we build our infrastructure. I mean, originally we would build our infrastructure manually and then test it manually. Then what we did was we built our infrastructure automated, and then we would test it manually. And then we thought, oh, let's use observability. So we set up our observability manually so that it observes our infrastructure. But with this, we automate that so that if you have 2, 3, 4, 15 clusters, they all get your full observability stack in 15 minutes. And you know that your whole infrastructure is correctly monitored. I mean, obviously, getting the dashboards and everything right in the first place isn't entirely trivial, but there's a reliable deployment. The same benefits that you get to infrastructure as code, you get with sort of observability as code.
Mm. Okay, great answer.
And just to say, I'm not sure I ever heard anyone say observability as code before. I'll remember that one.
I'm going to trademark that.
Yeah. Well, there's your next conference talk sorted. Malcolm.
Yes, absolutely.